Okay, now let's look at last problem, diet problem. It is pretty popular and famous problem where we can use linear programming. So diet problem, typical example is given here. So let's read the question first. So there is a turkey ranch. The name is Holiday Meal. And this ranch is considering buying two different types of turkey feed. One is brand X, the other one is brand Y. And now the problem is each brand of feed, X feed and brand Y feed, contains several ingredients. And each brand has different amounts of ingredients it includes, so A, B, and C. The problem is to feed your turkey, there are some minimum monthly requirements for each ingredient. It is very similar to humans' nutrition problems. For human, we have some minimum requirements for many different ingredients like let's say protein and different types of vitamin and something like that. Similarly, for turkey, we are considering three ingredients, and we need to feed those ingredients at least more than those minimum requirements level. However, here another problem is the cost of brand X and brand Y, they are different. So for each pound, brand X costs 2 cents, brand Y costs 3 cents. So if you want to mix this brand X and brand Y, and if you want to meet this minimum requirements level, what would be the minimum cost you can achieve? That is the questions. So let's try to solve the problems. First, as we have done before, we are going to formulate the problem, and then we will graph the feasible reason, and we will find the corner points, and we will decide the minimum cost by comparing all those costs for each corner point. So here, the first decision variable. What is the decision variables? We have to decide number of what's the dimension in this case? Pounds. So number of pounds of brand X feed and the number of pounds of brand Y feed. So given decision variables X and Y, we want to set up the objective function. The first one, we want to minimize objective, in this case, total cost. You can express your total cost in dollar amounts. If then, you may say 0.2x plus 0.3y. However, if you have decimal points, it's a little bit cumbersome when you calculate it. Instead, we can consider how about the cost in cents. In other words, we can just multiply this cost function by 100. If you minimize this cost in dollar amounts, actually you are minimizing your cost in cents as well. So in cents, your cost function is now 2x plus 3y. So minimizing your cost in dollar is just the same as minimizing your cost in cent. So you don't have to worry about decimal point. Now, let's consider constraints. What are the constraints? First, ingredient A. If you use X pounds of your brand, the first brand, and Y pounds of second brand, the total ingredient A you are feeding is 5X plus 10Y. So this total ingredient A must be at least what? Greater than or equal to 90. Similarly, second ingredient B, you can get the total amounts of ingredient B by using the formula 4x plus 3y, and that must be greater than or equal to 48. Now for ingredient C, since the second brand does not have any ingredient C, it is simply 0.5x that is greater than or equal to 1.5. For this constraint, just note that you can also convert it to by multiplying 10 each side. This is going to be 5x is greater than or equal to 15. Also, you can further simplify this one as x equals to just greater than or equal to 3. So it is all equivalent. So instead of using 0.5x is greater than or equal to 1.5, we are going to use this formula as the ingredient C constraint. Definitely, we have non-negative constraints for x and y. Okay, here we want to graph the constraints and the feasible reason. The first constraint is, let me write down here, 5x plus 10y is greater than or equal to 90. This equation, again, I can simplify by dividing each side by 5. Then x plus 2y is greater than or equal to 18. So this is the constraint. Okay, now how can we graph it? You can find the intercept, right? So when y equals to 0, what is the x value that can make 18? 18. When x is 0, what is the y value that can make 18? 9. So this is the first constraint with x-intercept and y-intercept. The second one is, let's say, first one. Second one is 4x plus 3y equals greater than or equal to 48. So if you try to find the intercept, let's say when y is 0, what is the value of x? So this value is when 4x equals to 48, so you will get 12. When x is 0, you will get the values for y. This y value is when 3y equals to 48, so you will get 6, so 16. The last one is you can easily get x is greater than equal to 3. So you have intercept just 3 and 0, and there is no y-intercept. So if you graphically represent this, it looks like this. So here is the graph, and based on the first constraints, so let me use the different color here. 18 is given here, and 0 and 9 is given here. And let's draw the lines here for the first curve. Now, second one, here 12 is given. So let's say there is 12. And here 16 is given. So let's say there is a 16. And we can draw this line. And this is the second constraint. The third one is greater than or equals to 3. X is greater than or equals to 3. So let me use this. So 3. And here we have this line. Since based on this, let's look at each of these constraints. The last one is greater than or equal to, so the right side region must be selected. And the second one, let's say red line, we have greater than or equal to, so this side. And the last one, blue line, is also greater than or equal to, and we have this side. So if you consider all three constraints together, the feasible reason, you will find this area. So a little bit better graph is shown here, and you can easily figure out how many corner points we have. 1, 2, and 3. Let's say this point is A, and B, and C. So let's try to find the corner points. First, this point A is just the x-intercept of this line. Therefore, this is 18 and 0. And the C, what is the corner point? Definitely x value is 3. And how can we find the y value? Y value is in this equations. Therefore, let's plug in x here. So 12 plus 3y equals to 48. And the 3y equals to 20. Let me see, 36. So y equals to 12. So we have 12 here. So 3 and 12. Now, how to find the b? B is kind of complex because we have to find the intercept of two linear equations. Two linear equation is this equation and the other equation here. So let me show you. So the first equation is x 4x plus 3y equals to 48. And the second equation is x plus 2y equals to 18. So I decide to cancel out this x as variable. So if it's 1, if it's 2, now let's multiply 4 in this equation 2. Then this equation is changes to 4x plus 8y equals to 32, 72. Okay, so now let's consider these two equations and I'm gonna subtract it. So let's subtract it. Then 4x is cancelled out. Minus 5y equals to 48 minus 72. So here 4 left and here is a minus 24. So what is the value of this y? Y equals to 4.8. Okay. And then if you plug in those numbers to x equals in this equation, either 1 or 2, you will get x equals to 8.4. So we have this corner points. So remember, just note that x1 means x, x2 means y in our case. So we can get this corner point B, that is 8.4 and the 4.8. So as the final step, let's compare the cost for three corner points. The first one, 18.0, so A. Second one is 8.4, 4.8. And the last one is 3 and 12, 3 and 12. So what was the cost function? The cost function is 2x plus 3y. So for A, if you plug in 2 and 18, so you will get 36 cents as the cost. And for B, 2 multiplied for 8.4 plus 3, 4.8, and then you will get 31.2 cents. The last one is 2 multiplied by 3 plus 3 multiplied by 12. So 6 plus 36 and 42 cents you will get. So what is the minimum cost? You will get this as the minimum cost. Also, just for better understand, I added a ISO cost line as well. So in this case, this line is called the ISO cost line. So similar to ISO profit line, if you choose any cost, you may want to reduce this cost as much as possible. So at point C, still you can reduce more. At point A, you can reduce more. Finally, when you touch this point, you will get the minimum cost. That's why we have this corner point B as the solution. So at point B, we have the minimum cost, and this is the value when x equals to 8.4, y equals to 4.8. So that's everything about linear programming. And I hope you now understand very well about linear programming and you can apply it in many different situations. Thank you for watching.